Hi, everyone. I'm Chris from the Developer Evangelism team at Amazon, and thanks so much for joining us in person. And for everyone online, hi, Mom. Quick shout out to CallStack and Meta for bringing back this event. If you've been at any of the recent React conferences over the past year, you may recognize my colleague, developer, and bouncer, Anisha.
Hey, everyone. Thank you. Hey everyone, I'm Anisha, Senior Developer Advocate at Amazon, clearly the bouncer. And unfortunately, bouncer duties do come with their risk, and I've injured my neck, so please, I apologize for the stiffness. I'm not usually so stiff, so please bear with me. But let me start by asking a question. How many of you shop online? Okay, expected. So when it comes to app development, choosing between React Native and native development, I feel like it's choosing between whether to shop online or visit a physical store. Native development is like shopping in store, where you have direct access to different products and can customize every aspect of the shopping experience. However, it also means you have to invest more time and effort into navigating through multiple stores to make your purchases. On the other hand, React Native is like shopping online through a global marketplace. I think we know what we're talking about. You can quickly browse multiple products, add to your cart, and have them delivered straight to your door. And if you're like me, that means a standing order of about 12 paper towel rolls per month. Similarly, React Native allows you to write your code once and deploy it to multiple stores, saving you time and effort. And as we just saw from Nico, many of our product teams at Amazon have embraced React Native for this exact reason, building iOS and Android apps for the same reasons that customers buy online: flexibility, scale, and customization.
So as you may recall from the tagline on React Native's docs, it's learn once, write anywhere. And for any of you Amazon customers in the room, a common catchphrase you might see on some of our packaging and products is, for streaming, is watch anywhere. And so our goal is to show you how React Native enables you to learn once, write anywhere, watch anywhere. So in other words, let's talk about how to extend your apps beyond mobile and desktop, why we're using React Native at Amazon, and which libraries are great for building apps across smart TVs, automotive, tablets, and a ton of other devices you likely use but have not considered it as an option to build for. As you can imagine, there's a handful of key factors to keep in mind for multi-device experiences. And that, my new React Conf friends, is where Anisha's going to dive in.
Thanks, Chris. So I'll be sharing the considerations for watching everywhere, or in the correct technical lingo, for scaling your app to multiple devices and form factors. Now, if you aren't already specifically working on a multi-device project and are thinking this is a good time to take a nap, just hold that thought, please. These considerations are just as relevant to your user's app experience. We're talking about performance, handling various user and device interactions, scalability. So by learning how to make your app, extend your app beyond mobile and desktop, you're also learning how to make it a best-in-class experience for your users.
So let's start with the obvious question. Why Amazon and React Native? Totally fair point. The truth is, Amazon's been using and been building with React Native for years. So recently, Anisha and I had the opportunity to add a handful of apps to the reactnative.dev showcase, including our main shopping app, Alexa for iOS and Android, Amazon Photos, Kindle itself uses React Native, and the Amazon App Store. I should also note that Amazon Music is also powered by React Native as well. As Anisha hinted a moment ago, these teams are using React and React Native for some of the main reasons that you chose to join us here today. So first off, it's faster development and it's simply cost efficient. Frugality is really important to us so that we can keep our customers' costs low. As you've likely experienced, a unified team can deliver more builds quickly. There's a strong third-party ecosystem, a lot of you in the room, for libraries and dev tools. These are benefits I don't need to explain to this room. And also just delivering a consistent user experience while allowing custom native functionality. And so, but mainly, we have a lot of devices. And with React Native, we're able to reach a balance between code reusability and the reality of customizing for native functionality. And so, quick show of hands. I actually can't really see anyone. Here we go. Quick show of hands. How many of you have ever owned or own an Amazon Fire tablet? OK, keep your hand up. What about a Fire TV? OK, how about like a Fire streaming stick? And what about an Amazon Echo or Alexa device? OK, for all of you with raised hands, Anisha and I thank you for your business. Start hucking out sticks here. If you're not familiar with Amazon's devices, it includes our collection of smart TVs, streaming media players, tablets, actually in-car entertainment systems. We launched our first Fire TV stick 9 years ago, built on our implementation of the Android open source project. We call this Fire OS. Existing apps built for Android with Java, Kotlin, React Native, Flutter, and other cross-platform frameworks can be ported, sorry Flutter, tough week, can be ported for publishing to both Google Play and Amazon App Store. So if you check out our docs and our SDKs, you'll see a majority of our efforts are to make it easier to help you build across multiple digital stores. Today, there's hundreds of thousands of developers building apps for Amazon devices, and we actually now have over 200 million Fire TVs around the world. So we believe that building with React Native allows our teams and you to build apps for multiple devices that feel native to the hardware that they're running on while maximizing developer productivity. Coincidentally, a few years after we launched our first Fire TV stick, so I guess 7 years ago, React Native Core started to add support for TVs. So hallelujah. Support for Apple TV was introduced in 0.49. So that 2017, that was 7 years ago. We're getting old, Anisha.
Tell me about it.
And in the following year, pull requests for Android TV were merged starting in 0.55. So this was just the beginning of better TV support for app developers. In fact, since 0.62, all these TV efforts have been forked into one of the most popular TV libraries today, React Native tvOS. I'll note it's a little confusing that this package actually works both for Apple tvOS and Android and Fire OS. This is a fork of React Native. It's kept up to date with Core along with essential TV-specific features like better focus management and access to touchable controls with TV remote support. And we have to give credit where credit's due. We are here at React Conf today because of legends such as the entire Expo team, Doug Lauder, David Vaca, Yusuf Yildirim, and many, many others that have been working tirelessly to make React Native an excellent solution for building TV apps. While these community efforts for better TV support are remarkable, there's plenty of pain points to solve for when building for multi-device experiences. In fact, there was a recent episode of the React Native show. It's great. Subscribe. Check it out. Where Lukash.
Wait, sorry, Chris, hold on. We've got a celebrity in the crowd.
Do we have a Lukash in the room? Okay, hey. He does autographs. So yeah, I was watching a recent episode for Building for TV, and he lays out this perfect quote to describe what we're up against when building for TVs. So he says, the streaming media market is very fragmented. It's like a very honest quote. Nothing like we see in web, Android, and iOS. In order to build applications in a purely native way, you need at least 5 to 10 different teams capable of building apps for Tizen natively, WebOS for LG natively, Apple and Swift natively, Android, Roku, and so forth. And so when it comes to this fragmentation, of course, React Native comes to the rescue. And I feel that quote very strongly. The point is, if you're building web apps, so for the React crowd here, we're mega jealous. Because whatever your app does, it not only has the power of a desktop computer, but is able to harness the magic of server-side rendering that we've already heard so much about today and yesterday. And don't get me started with the mobile app devs in the room. So iOS and Android represent 95% of the total mobile OS market share and are effectively tiny supercomputers running your apps. So I'm curious, how many of you are already building apps for smart TVs and related devices? Okay, I'm sure those handful of people can agree. It is really hard, or in the least, it has its challenges. Sometimes it might feel like you're being strapped to a rocket ship on wheels, driving over 230 miles an hour. That's 140 degrees inside, so that's 60 degrees Celsius.
Sorry, guys, it's the better measurement system, the British one.
Right, hoping for ridiculous amounts of funding and an Eng team that has to complete patch updates in 3.2 seconds. So for us, is this Formula One or is it startup life? And funny enough, there's some rather interesting parallels between the world of F1 race car building and the realm of developing multi-device apps. If any of you tuned into CallStack's React Native EU conference last year, you might recognize this absolute boss of a technical leader. Anisha, tell us who we're talking about.
It's my favorite person, Gunther Steiner, and I was really lucky to meet him at CoStack's conference. For those of you who don't know, Gunther is a ex-F1 team principal. And so you might be thinking, while you might feel like the driver, consider him your typical overpaid yet overworked engineering manager like Chris over here. So what would a React Native developer like myself have in common with him, other than obviously a background in mechanical engineering and a great sense of humor? We're both working with budget limitations that require thinking through resource allocations. For him, it's spending caps to avoid race fines. For me, it's thinking about how to maximize my code reusability and maintainability to ensure my apps can run on everything from smart TVs to smart cars. Fortunately, not yet F1 cars. That would be a bit dangerous. But we both work in domains that require continuously optimizing our performance. For him, it's every millisecond of the race clock and reducing drag. And for me, it's every percentage of CPU to ensure my apps don't lag. We're building products that adapt to changing conditions, him with racetracks and mine with diverse user interactions and device-specific APIs. And in terms of keeping it real, he once dropped over 0.26 F-bombs per minute on Netflix's Drive to Survive. And that's about half my rate when I'm trying to navigate through dependency hell while I'm trying to upgrade my NPM packages.
This is true.
Sorry, Chris.
I'm a witness.
So, at a high level, these are the three main factors we need to consider when building apps for multiple devices: code reusability, user and device interactions, and performance. So let's first start with code reusability. And why? Because reusability equals to scalability. When thinking about code reusability within our app's architecture, ask yourself, what can and should I be reusing across each OS and device form factor? First, let's have a look at a typical app stack. We've got our business logic, things like APIs, config, custom hooks. And in my opinion, and in fact, a lot of people might agree, people put them in separate packages. And I don't want to get started on the mono versus multi-repo war, but these things are still quite reusable across the stack. Next, we've got app state. So as you might have noticed, all the state management libraries can be used in React Native and React in the same way. And so I believe app state is very reusable across the board as well. Then we've got navigation logic. And this is where things might need to be customized a little bit. Navigation logic can be similar across form factors, but the implementation details may vary slightly depending on what device type you're using. In mobile apps, it's typical to have a stack navigation, whereas in web apps, you're used to the URL navigation. So this is where we might have to customize things. And next, when we have the UI, we've got three parts of it. The design tokens, which since they're mainly variables, are very reusable. We've got components that might vary on a case-to-case basis, which we'll have a look at in a few slides. And we've got our layout, which is probably the one thing that you will have to make sure is customized for each form factor. But what's really great is that the technology for universal apps, which are cross-platform React and React Native apps, using the React Native for Web package, provide a great foundation for code sharing. Let's look at an example. Here's Zigo. It's a package that lets you implement native menus. And as you can see, with the same code base, you get that same native look and feel on both web and native. Features such as navigation and UI components are exactly where the React Native community libraries are leading the way to help close that gap between web and mobile development. We saw libraries like Expo Router yesterday from Evan's talk, and Solido, and these libraries for navigation are significantly helpful when you're building that shared navigation structure across devices. They offer that common API that helps you define routes and handle navigation logics while customizing under the hood for each form factor. Similarly, UI libraries like Tamagui and GlueStack offer a wide range of pre-built components that can also easily be customized for different platforms. Thanks to libraries like these, the primary consideration when building multi-device apps is implementing custom layouts. Though, we'll soon see it's not the only one, but a lot of the work has been done for us, and we're really grateful. Hence, by leveraging the magic and power of the React Native third-party ecosystem, we can create apps that provide a native feeling experience across multiple form factors while maximizing code sharing. However, while this is great for most form factors, we know there are challenges and room for improvement in this space when it comes to TV. And we are actively working to address them, as well as looking to you guys, the community. Later, make sure to check out Olga and Naman's talk on cross-platform React. It's at 4 o'clock, where they'll cover how their teams are working together to bring the UI stacks together.
So now we've seen what's reusable, but let's talk about device-specific customizations. With a broad selection of device form factors and capabilities, you need to anticipate how your users will interact with your app and how to make sure that they're having an ideal user experience. For example, user inputs, navigation, and focus management for TVs are just built different. Why is this such a streaming media specific issue? For starters, take your favorite apps you like to watch on mobile phones, and what you'll notice, sorry for the blurriness, trying to keep our copyright lawyers happy, is the obvious. So pretend those are the apps you love. Didn't do a good job blurring. The obvious thing is everything is so tappable. However, when building for TV apps, there's two main inputs you have to consider. So one is built-in voice search, right? So for us, it would be Alexa voice search. Most TV providers have some type of search solution. And the other one is I feel like a car salesman here, is your standard TV remote control. Up, down, left, right, select. It's sometimes called a D-pad. These are very different input options than tapping, keyboard, mouse. Then you need to account for them in order to build beyond web and mobile apps. React Native's docs do a great job walking through touchable mix-ins, pressable controls, and how to set up key TV remote events. Here's an example of implementing the TV event handler that allows your app to handle remote control events, and listen to them. Within streaming apps, it's not just user input, but it's think of how you, when you're watching TV at home on a larger screen, how you navigate. You'll likely notice that most TV apps are primarily a two-dimensional grid experience, often known as spatial navigation. If I was to oversimplify the basics of a TV app in my substandard sketch here, it would be a home screen, a list view, and a detail view. Besides that, it's most often just simply full-screen media playback. And so let's have a look at a typical smart TV app experience. Shout out to the team back home. Everything you see here is AI generated or they designed themselves. So again, keeping the lawyers happy. Have you ever thought much about that logo that shows up when you open a TV app? Usually it's like the app's logo, like tudun. That's loading in resources, assets before the UI shows up. And then you have your typical navigation drawer. And what we're looking at is what we refer to as spatial navigation. When we eventually get to a detail page, then you'll usually see some recommended videos and some options, perhaps buying, purchasing. It's my favorite show. This is a tearjerker here. And yeah, I guess this is my other, let's go LARPing. Okay, notice with every action and corresponding key event, I'm changing what's in focus with that remote control. So how is this handled? So focus management is a common challenge that many first-time React Native developers struggle with when building for TV apps. Think of some of the common questions we're stuck with, right? So where should active focus be at any given time? Where should focus transfer to following a remote control key press? Should we allow for more than just the remote control as inputs? Yes. Thankfully, there's a few common ways to address this. In React Native tvOS, the project I mentioned earlier, let's look at one of the common components, TV Focus Guide View, and how it works. So this component allows for focusable controls that can be navigated to even when they're not directly in line with other cards. So very commonly going from the top navigation over to the next card or going through another row. It also helps you manage focus between TV UI elements and navigating past it's not a scientific word, gaps, where there's just simply empty space or regions where focus could get lost. It gets more complicated when you think of all the different TV size resolutions and dimensions, and those things can resize on screen, and you've got to think about the logic. It's not as simply as marking to different quadrants and pixels.
So we've seen how to handle user customizations, but what about those native device customizations? At Amazon, we do have our own APIs for things like in-app purchasing, advertising, voice search, and more. And while you might be thinking, okay, great, another device customization I have to handle, my team's going to be so happy. The good news is there are already React Native community libraries that support not only iOS and Android, but our Amazon APIs too. A great example being the React Native IAP package. And to reiterate, this is the real point. We want to support more projects like these to help bridge that gap and make multi-device and multi-platform development easier. However, if you do want to make those native customizations, we recommend using turbo modules. These next iteration of native modules that we heard about allow for faster app startup by bypassing that JS bridge, allowing you to directly communicate with the native code, reducing the overhead between JS and native code. Which brings us to our last consideration for multi-device development, performance optimization. Consider the processing power of a Mac M2 or a new iPad versus a streaming media player. It doesn't compare. Therefore, performance optimizations are essential, since any perception of UI delays can lead to user churn. A great example is another community package, React TV Space Navigation, from the team at Theodore and BAM. And if Pierre and Mo are watching, hey. Some of you might be familiar with the performance limitations that arise from the default flat list option in React Native. But with flash disk as an option, why was there a need for a third solution? The BAM team knew that when building for TV devices, optimizing list and carousel performance was critical and can have an even more noticeable effect on the user experience. The outcome was this project that allows us to optimize TV app performance even further with custom list implementations specifically for spatial navigation on TV that Chris showed us earlier. Let's have a look at their example. First, we have a simple component that uses their focusable view plugged into their scroll view, which then forms the raw layout that we typically see on TV. These sideways scrolling lists of content are then included on a screen that has a vertical navigation scroll view, which is all then wrapped up into the root component that contains all the spatial navigation nodes. It's not that dissimilar to what you might see from a typical list, as you can see.
Unfortunately, Hopix is not a real streaming station either. Sorry.
No. Running this example, you can see projects' use of virtualized spatial lists outperforms flat lists on every metric, notably requiring 32% less CPU power, which is amazing. You can read more about this article on rntv.dev, a blog maintained by the team at BAM and ourselves dedicated to React Native on TV. What about at a high level? Right? When it comes to performance optimizations, our host, Callstacks, wrote the book, which they're actually giving out for free outside, so grab yourself a copy. Make sure Lucas autographs it. You can sell it later. However, since the guide is primarily focused on React Native for mobile development, let's examine those main principles and apply it to our goal of building beyond mobile. First is understanding the React Native implementation details and learning how to maximize them. This is a topic I'm personally very passionate about. And in my latest article, I walk through the evolution of React and how it created these two generations of React, which caused these unintended consequences of not understanding details that can lead to unnecessary UI re-rendering, which majorly affects performance.
All right, I'll admit, during the last sprint planning, when I saw a scope ticket for a love letter to React Native developers, I had my doubts, but definitely check it out. It's really good.
So what does this mean when it comes to building beyond mobile? Let's consider an example. Last month, when building the Fire TV demo app, I had to carefully evaluate my state management options. I wasn't just procrastinating. This decision was crucial for not only minimizing potential re-renders, but also due to other factors that come into play when it comes to multi-device development. When making choices for multi-device apps, it's even more essential to think twice before selecting a library. Because when it comes to lower-powered devices like Fire TV Sticks, there are other considerations, like library package size, memory usage, CPU utilization, which can have a really big impact on the app's bundle size, initial load time. Additionally, having an accessible and reliable, consistent developer tools across the array of devices that we have to adapt for will leave you and myself less likely to throw my laptop out the window. Another way to improve performance is by activating the latest features of React Native, like the new architecture. The new architecture, as we heard, for React Native supports concurrent rendering and features that were shipped in React 18, which means now you can use features like suspense for data fetching, transitions, and the other React APIs in React Native, which I just think is amazing. So why does this matter again in the context of building beyond mobile? Well, I'll go back to my example of state management libraries. Libraries like Jotai, Valtior, Recoil, they all were designed with concurrent rendering in mind, and they already leverage React suspense. So they are, right now, well-positioned to take advantage of the performance improvements offered by the new architecture. And this was a key factor, again, for making that choice of what library to use for TV. Finally, The last factor to consider is enhancing the stability of apps through adequate testing and CI/CD. And in the context of multi-devices, this is particularly important when developing for TV, as the unique characteristics of these devices introduce additional challenges, like testing for various input methods. When it comes to testing for TV, choosing what to test is crucial. Developer tools like Appium for automation, Flashlight for performance, Charles for network proxying are all available right now to build apps for Fire devices. Make sure you prioritize testing scenarios that cover the most critical aspects of the user experience that we spoke about, like navigation, user input handling, and performance. And to help you, Amazon also offers dev tooling such as Systems X-Ray, Live App Tester, and IAP mock flows to help you with launching your TV apps. So, to wrap up, whether you're building for multiple devices or not, make sure you consider these three factors: performance, scalability, and handling those various user and device interactions. But if you are building for multiple devices, using React Native will have you feeling like the F1 driver, accelerating your development. I know that's cheesy, just bear with me. And when it comes to anything, any sport, any community, what is a community without its fans? And while it's obvious Chris and I are diehard F1 fans, I literally was fangirling over Gunther. You can ask the post-stack folks. We are equally as excited about the React Native community. Since React and React Native are community first by design, we know it's on us to both contribute to these projects and to better support you guys, the developers, who are considering publishing your apps to Amazon devices.
And to that end, I want to share 3 ways we'd love to help today. So first, we invite you to publish React Native apps on the Amazon App Store for Fire TVs, tablets, Echo shows across the global world of our Amazon customers. Myself and our whole team are here to guide you. Either way, swing by our dev lounge for some folks. We got a lot of socks. I can't bring these all home. These are spatial themed. See what I did there? Theme socks. Please come by. We'd love to meet you and just take our swag. We also know that launching apps require a sizable investment in your backend infrastructure and dev work. So to better support developers new to Amazon devices, we launched a program that provides 10% of your App Store revenue back to you in the form of AWS credits. In addition to app building, we know it's a lot of work for third-party libraries, both maintainers and contributors, to even know upfront if their open source project works out of the box. So we're offering up a new set of office hours dedicated to libraries where we'll help you test and confirm what's required to support Amazon devices. And in addition, we're very excited to launch our first open source funding specifically for React Native community libraries. If you're interested in launching apps on Amazon devices, we'd love to support you and help you go live. So scan our QR code. Scan our QR code and let us know. In addition, if you maintain a React Native library or our a frequent contributor project that you're passionate about, we're excited to learn about your project as we're evaluating more ways to support you through open source sponsorship. I think in the form, there's a little conditional where you can check if you're React Native library, and we love to actually know your GitHub or NPM package. Either way, make sure to answer the drop-down, and we're excited to get to know you.
If you aren't already, you can follow us on our socials, or you can check out some of the other content that we've created that we've mentioned throughout this talk and more. But if you have any questions, you want to follow up, we'll be hanging out outside in the main hall. Thank you so much. Thank you to the community. We can't wait to support you.
Thanks, y'all.